Hello and welcome to Mr. Hopkins Maths. Today we're looking at binomial distribution. We're going to look at mean and expectation and the variance. So if, as we know, the x is distributed binomially, with n being the number of trials and p being the probability, then the mean or expected value equals mu, which is the mean, which equals e brackets x, which just stands for expected value, which is n times p. So number of trials times the probability. So let's look at this in more detail. How is this working? So if we want to work out the expected number of ones I'll get when I roll a fair dice 30 times and then interpret our answer. So let's look at that. So let the random variable x be the number of ones in 30 rolls. So we know that I'm going to be doing 30 trials and each has a probability of 1/6. So the expected value of x, that's e brackets x, is just going to be n times p. So that's the number of trials, that's 30. And we're going to multiply that by the probability, which is 1/6. And I'm going to get 5. So I would expect on average 5 ones when I roll my dice 30 times. Which seems reasonable. 1/6 of the time, fairly straightforward kind of idea there. So what does an expected value of 5 actually mean? Well, it means if I roll my dice 30 times and find the average number of ones in each batch of 30 rolls, I would expect my average to be about 5. Now, this won't always be the case because, as we know, theoretical probability and experimental probability don't always line up. However, if I did more sets of 30 rolls, we would then expect our average of our number of ones to average towards 5. So it seems to be more of a long-term average that we're looking at. So this is an important point. So although the probability of getting 5 ones is 0.192, okay, so we're more likely not to get a 1 at 5 ones than anything else. The mean is just our long-term average. So while it might not work out in our first batch of 30, over time, we would expect our average of all of these batches to tend towards 5. So the variance and standard deviation can be calculated using a similar way. So the variance, and we would write that as var of x, along with this symbol, because remember, variance is standard deviation squared. That's np times 1 minus p. Now, p is the probability of success. And so 1 minus p is failure, or what we don't want. And we tend to write that 1 minus p as q. And in standard deviation, it's just this square rooted. Reasonably straightforward. So it's just n times p times q square rooted. So if I want to work out the variance and standard deviation, if we've got x distributed binomially, 400 trials and a probability of 0.1, first I want to find q, which is 1 minus p. So q equals 1 minus 0.1, which equals 0.9. And then I use the formula for variance, which is npq, which equals number of trials, which is 400, times 0.1 times 0.9, and that's going to work out as 36. And then to find the standard deviation, so I just take the square root of 36 and I'm left with 6. So I have a standard deviation of 6 and a variance of 36. Okay, so a more complicated example. A random variable x is distributed binomially with a fixed number of trials and a probability. Now, we don't know how many trials and we don't know the probability. So if the expected value is 5 and the variance is 4, find n and p. What we have to do first is we have to write down what we know about e to the x and the variable x. This will give us two equations involving n and p. So we know that the expected value is np, so n times p, which gives us a value of 5. And we also know that the variance is 4. And that's from n times p times q. The next thing we want to do is divide the variance by e to the x. So we want to do variance divided by the expected value. And that means we're going to be getting something in terms of q. So what we're doing is we're going to get npq divided by np. So that's all going to cancel out and we'll be left with q, which as we know is 1 minus p. Now in our case, that is the same as 4 divided by 5. So 1 minus p is 0.8. So we know that 1 minus p equals 0.8. So p equals 1 minus 0.8, which is 0.2. So we've now found our probability. And the key to this then is, as I know that n times p equals 5, I know that n times 0.2 equals 5. So all I now need to do is to divide 5 by 0.2 to get my value of n. And then we now know that n equals 25. So we've found our n and we've found our probability. So that was a more complicated example involving expected value, or the mean, and variance, or standard deviation, because both can be found from each of those. Next video, we're going to be looking at how to apply everything we've done in these 3 videos on binomial distribution all together in a real life situation. If this video has been useful for you, feel free to like, and remember to subscribe so you know when the next video is coming out.